Okay, Module 24, Technologies and Protocols. We're winding down towards the end here. This one is going to look at our monitoring various common protocols that we've seen before, as well as different security technologies that affect the ability to be able to monitor these network protocols. So the main ones that we use for monitoring are going to involve Syslog and NTP, or Network Time Protocol. Those are pretty much essential to make sure that we have everything on the same time, as well as a general collection of all the logs from the different devices that are out there. So syslog is used as a standard for logging event messages from different network devices or endpoints. The standard allows for a system neutral, meaning that the transmission, storing, and analyzing of those messages can be done at a central location. Many types of devices can be used from different vendors. They can all be configured to use syslog to send those log entries to central servers running a Syslog Daemon. And so this centralization of log collection helps make sure that security monitoring is practical. It also makes sure that everybody is using the same time, and that's what the NTP will come up to. So syslog itself runs on UDP port 514. And it's important for network monitoring because it may be a target for threat actors. So syslog itself needs to be a little bit protected, particularly the system that's running there, as they like to get in there to remove. Once they've gone in and collected all the data that they wanted to get, they'll try to exploit the logs so that they can clean up any traces of them getting in. So some of those exploits, including data exfiltration, can take a long time due to very slow ways in which the data is stolen from the network, and therefore they're trying to hide what's going on during that. To attack the syslog servers that contain the information that could lead to the detection of the exploit. They may attempt to block the transfer of data from syslog clients to servers, tamper or destroy the log data, or even tamper with the software that creates and transmits the log messages from the beginning. So the next generation of syslog, or NG, is known as syslog-NG, and this offers enhancements that can prevent some of the exploits that target syslog. NTP syslog messages are usually timestamped, and as messages are coming from many devices, it's important to make sure that all devices are using a consistent time clock, and that can be achieved using NTP, or Network Time Protocol. NTP uses a hierarchy of our authoritative time sources in order to time share that information between devices, and that runs on UDP port 123. So threat actors may attempt to attack the NTP infrastructure in order to corrupt that time information used to correlate logged network events. So if they're, creating a distributed denial of service across these vulnerabilities, that can disrupt the time, and therefore it's harder as an analyst to try to match everything together in the main syslog server if everything's running off the same NTP. You could also inject different variances in time, which is what would happen if you didn't have an NTP server. You would have variances between different systems. DNS itself is now used by many types of malware. So varieties of malware use DNS in order to communicate with command and control servers, in order to exfiltrate data and traffic in disguise as normal DNS queries. Malware can be used to encode stolen data as subdomain portion of the DNS lookup for a domain where a name server is under the control of an attacker. So what this means is it will take a DNS lookup for a long string of exfiltrated data.com, etc. This could be a subdomain within a DNS that they own. That would then be forwarded to the name server of example.com, in which a record of that long string of exfiltrated data would be replied back to the malware with a coded response. And this use of DNS subdomain is shown in this figure. The exfiltrated data will come in here. So what they're doing is instead of going in finding a bunch of data that's going to come, and they're going to try to figure out how to get that out, right? You probably have firewalls on either the end device or something in between, which is normally going to block them from being able to send raw data back out to the real world or to the internet. So as a way of counteracting that, what they'll do is they'll base 64 encode whatever data that comes in there. That way it's somewhat obfuscated. You can't just see clear text. And then they do queries to a particular domain with that base 64 data. if the DNS server side is compromised, when it sees these requests come in, it just strips off what they're actually looking for and dumps that down as data. Of course, nothing actually happens, but on the inside, it just looks like regular DNS queries going across there. But then this compromised data DNS server that's over here will strip this portion of it off, being the subdomain, then decode this with base 64 and get the data that they're originally looking for. And unfortunately, the network is really none the wiser here, because it still thinks, and you have to allow it to look up various DNS requests that go out here. Now, this particular DNS server, it's not like they're going out there and just purchasing one on the internet and then setting it up. They generally compromise somebody else's DNS server. So if they've already compromised a DNS server, they're able to set up these various requests so that when this comes in there, it can be coded back. They could also send directly to a subdomain that they have. And if that subdomain that comes in there, they can pass the data that's already been base 64 encoded through there as well. So they could set a string of data, which is a record, like a text record, that could be used to look up and pull that data down. That's another way to pull it back down to the system itself. So like this is going to be a query going out to the DNS server. If they need to pull some kind of code down from the internet back down, what they can do is go look up a DNS record over here that's a text. It's base 64 encoded. When they pull that code down, then they de-encode the base 64, and now they have that little snippet of data here on this side. That will allow it to pass through the network undetected, because it's mostly DNS traffic as it goes through there. So it's likely that that subdomain part of such requests would be much longer than usual requests, and therefore cyber analysts can use distribution of links of the subdomains as DNS requests to construct a mathematical model to describe a normality. And they can use this to compare their observations and identify abuse of DNS query process. For example, it would not be normal to see a host on the network sending a query to, and then a base 64 string, example.com. Those DNS queries should be randomly generated domain names or extremely long random appearing subdomains, which would be considered suspicious, especially if their occurrence spikes dramatically all the time on the network. So again, DNS proxy logs can be analyzed to detect these conditions, and alternatively, Cisco has services such as Cisco Umbrella, passive DNS service used to block requests that are suspected of CNC and exploit domains. With the HTTP and HTTPS protocols, these are the backbone of the World Wide Web. So all information is carried across HTTP, is transmitted in plain text from a source computer to a destination on the internet. And HTTP doesn't protect data from alteration or interception by malicious parties, which is why it's a serious threat to privacy, identity, and information security. And all browsing activity should be considered a risk. So a common exploit of HTTP is called an iframe. This is an inline frame injection. An iframe injection is going to be a threat actor compromises a web server. They plant malicious code which creates an invisible iframe on a commonly visited website. When that iframe loads, malware is downloaded, and frequently from a different URL than the web page that contains the iframe code. And therefore, network security services such as things like Cisco Web Reputation Filtering can detect when a website attempts to send content from an untrusted website to the host, even if it's sent from within an iframe. So it used to be a pretty good development tool with web developers and such to put things in iframes, etc. Now, these days, it's very limited that they do that because you have things that are sitting out there. So you could have a small frame inside of this main Cisco.com if it's compromised. And that little frame is going to load code. Now, whether that's JavaScript code today, or maybe that's some other HTML code that causes it to download malware to the system. You look and feel just like you're at Cisco.com, but it's their main web servers that have been compromised. So to address that alteration of confidential data, many organizations have adopted HTTPS or implemented HTTPS only policies to protect visitors to their websites and services. That HTTPS adds a layer of encryption to the HTTP protocol using SSL, and that makes HTTP data unreadable as it leaves the source computer until it reaches the server itself. It's not a mechanism for web server security. It only secures the HTTP protocol traffic while it's in transit. So you still need some kind of service to protect your web server itself. This just protects the transmission of that data. So unfortunately, the encrypted HTTPS traffic complicates network security monitoring. Some security devices, including SSL decryption and inspection. However, this can present processing and privacy issues. HTTPS adds complexity to the packet captures due to the additional messaging involved to establish the encrypted connection. And so this process is kind of summarized in this figure here. But the idea is that now you have this extra layer of security, which is great for the end user, but it makes monitoring and processing that information as a network or a cybersecurity analyst a whole lot harder. For email protocols such as SMTP, POP3, and IMAP, it can be used by threat actors to spread malware, exfiltrate data, provide channels to malware, CNC servers, and shown in this figure here. And so SMTP data from a host is a mail server between different mail servers. IMAP and POP3 are used to download email from a mail server to a host computer. Those are an application protocols that are responsible for bringing malware to the host itself. Security monitoring can identify when malware is in attachment to the network and when the host first is infected. ICMP, we've used this before in order to identify hosts on the network, the structure of the network, and determine which operating systems are at use on the network. It can also be used as a vehicle for various types of denial of service attacks. So ICMP can be used for data exfiltration. Because the concern that ICMP can be used to surveil or deny service from the outside network, ICMP traffic from inside the network is sometimes overlooked. And so various varieties of malware can use crafted ICMP packets to transfer files from infected hosts to threat actors using a method known as Icmp tunneling. So again, what they're doing is they're taking Icmp, which most network guys want up and running inside their network, and you're going to be able to use ping and things like that on the inside. You don't want to allow ping from the outside. We all know that's bad, and you can cause denial of service attacks. But once a threat actor's on the inside, then what they're doing is now re-encoding this data inside ICMP packets, which are more than likely whitelisted within the firewall itself, or any kind of IDS, IPS, that kind of thing. So you got to remember to monitor ICMP packets as well. So different ways that we use to mitigate this type of thing. ACL, or access control lists, is a packet filtering technology used to contribute an evolving set of security protections. This figure shows how they use ACLs to permit only traffic of Internet Control Message Protocol, or ICMP traffic. The server at 192.168.1.10 is part of this inside network, which you see here. And it's allowed to send ping requests out to the outside host of 209.165.201.3. However, the outside host return ICMP traffic is allowed if the ICMP reply or ICMP unreachable message. So any other types of ICMP traffic are denied, which means you can't be sending traffic in this direction and out. You have to be able to send traffic from here out this way so that it replies back through. And so attackers can determine which IP addresses and protocols and ports are allowed through these ACLs. This can either be done by using port scanning or penetration testing or other forms of reconnaissance. The attackers will then craft packets using spoofed source IP addresses. That way it bypasses those ACLs. And applications can establish connections on arbitrary ports. So other features of protocol traffic can be manipulated, such as established flag and TCMP segments. Rules cannot be anticipated and configured for all emerging packet manipulation techniques. So in order to detect and react to that packet manipulation by the threat actor, more sophisticated behavior and context measures need to be taken. And this is what you'll see within Cisco next generation firewalls, or AMP, web and mail content appliances that are able to address those shortcomings of basic rule-based security measures. You should be familiar with NAT and PAT. Again, NAT being network address translation, PAT being port address translation, and they can also complicate security monitoring. So from what this figure shows here, the relationship between this internal server that you see over here and this external address that's used over here. And then they have the source address that comes through here. So on the source address over here, you're going to see it as 192.168.10.10 with the destination going out to 201.1. However, the moment it gets through this firewall, it now shows the outside IP address of this router coming in here and then going out to this side. Same way when a packet comes back, we don't necessarily know because this part gets stripped off as it goes through the firewall. And so PAT itself is in effect and it can be difficult to log specific inside devices that are requesting and receiving traffic as it enters the network. And so this problem can be relevant to net flow data. Net flows are unidirectional and therefore defined by addresses and ports that they share. So in other words, your traffic can be re-encrypted and sent out if you're going through a NAT, which today is pretty common. Encryption can also present challenges to security monitoring by making packet details unreadable. So encryption is part of VPN technologies, and VPN's IP is carried over encrypted traffic. And this encrypted traffic essentially writes and establishes a virtual point-to-point connection between networks over public facilities. This can make traffic unreadable to other devices other than the VPN endpoints, and therefore a similar technology can be used to create a virtual point-to-point connection between an internal host and threat actor devices. Malware can be established an encrypted tunnel that rides on a common trusted protocol and then used to exfiltrate the network. So instead of trying to go out to the internet and advertise to the routers and switches and firewalls, et cetera, that they're looking for an outbound connection, they simply set up their own VPN from the inside going back to their home or some other location that allows them to transfer that data encrypted over that network. We can't stop that encrypted data because we don't know what's in there. And if we stopped all encrypted data, then no VPNs would work on the network. You also have peer-to-peer networking as well as Tor. So peer-to-peer or P2p networking is shown in this figure here. It's used to operate in both client and server roles. There's three types of P2P applications, such as file sharing, torrents, processor sharing, and instant messaging. In file sharing, these P2P networks, the files are participating on machines or shared with members of each of these networks. Bitcoin itself is a P2P operation, and BitTorrent is also a P2P file sharing network. File sharing peer-to-peer applications should not be allowed on corporate networks. P2P network activity can be avoided. Whoops, sorry about that. By firewall protections, and it's a common vector for the spread of malware. So you could have things that are spreading malware just by creating these peer-to-peer connections. So you should be blocking this on a corporate network. There should be no reason to grab from these particular style of networking. Because of its nature, peer-to-peer is inherently dynamic, and therefore it can operate by connecting to numerous destination IP addresses, and it can also use dynamic port numbering. So therefore, processor sharing peer-to-peer networks can donate processor cycles to distributed computational tasks. Cancer research, searching for extraterrestrials, scientific research, all use donated processor cycles to distribute these computational tasks. Instant messaging is also considered to be a peer-to-peer application. While instant messaging has a legitimate value within organizations that are geographically distributed across project teams, in which case specialized IM applications are available, such as WebEx for Cisco Teams platform is more secure than just using public IM that's using public servers. And this is where your Slack and things like that will start to come into play. Tor itself is a software platform of a network of peer-to-peer hosts that function as internet routers on the Tor network. So the Tor network allows users to browse the internet anonymously. The users access the Tor network by using a special browser. When the browsing begins, the browser constructs a layered end-to-end path across the Tor server network that's encrypted. So this is typically used to access things like the dark web. You have a threat actor that's over here using Tor software. It's going to create connections through multiple hosts out on the internet that are all tied together. And then it sends that traffic on out to the exit node and destined out there to the internet. So the idea is that you're not showing your public IP address. You're actually bouncing through multiple hosts before you go out and connect to your end data. Each encrypted layer is peeled away like layers of an onion, so you may hear onion routing being used as this reverses and traverses the Tor relay. So these layers are encrypted next hop information that can be read only by the router that needs to read the information. In this way, no single device knows the entire path to the destination, and routing information is readable only by the device that requires it. And finally, at the end of the Tor path, the traffic reaches the internet destination. When that traffic is returned by the source, an unencrypted layered path is again constructed. Tor represents a number of challenges for cybersecurity analysts. First, Tor is commonly used by criminal organizations for the dark net or dark web. Tor is used as a communications channel for malware and CNC. And as a destination IP address of Tor traffic is confused by encryption, with only the next hop Tor known, then Tor traffic avoids blacklist because they've been configured on security devices. So again, it only knows the next hop that makes its way through there. It doesn't ever know the full path. We talk about load balancing in terms of security. This involves the distribution of traffic between devices and network paths to prevent overwhelming network traffic and resources, commonly used for web servers, but they can also be used for DNS servers. If the redundant resources exist, then a load balancing algorithm or device will use it to distribute traffic between those resources, as shown here. One way this is done is through techniques that use DNS to send traffic to resources that have multiple of the same domain name, but multiple IP addresses going out. So when a request comes in, it just doesn't always get resolved to one IP address. It could do a round robin approach through there in order to delegate the traffic between multiple servers. There's many different algorithms that are out there for load balancing systems. In some cases, the distribution may be to servers that are geographically distributed. This typically results in a single internet transaction, which can be represented by multiple IP addresses on incoming packets. This may cause suspicious features to appear in packet captures. Also, a lot of load balancing manager devices use probes to test for performance of different paths, as well as the health of different devices. A load balancing manager may send probes to different servers that are load balancing traffic in order to detect the servers that are operating. This is done by sending out and avoiding sending traffic to a resource that's not available. These probes can appear to be suspicious traffic on a cybersecurity analyst that's not aware of that traffic being part of a load balancing manager. So think of this more as false positives when you are trying to analyze data. Load balancing managers are intended use and they're appropriate for their use, but it can start to look like random data that shouldn't be there kind of thing. You're trying to access data from multiple IPs versus one single. So to summarize technologies and protocols, Syslog is going to be the main one that uses the Syslog Daemon. The new version of this is Syslog NG. Again, Syslog is a central location of logs that helps the network security monitoring protocol practical and able to use it. They're usually time-stamped, and therefore those messages come from many devices. So it's important that all devices share a consistent time clock, NTP, using the NTP protocol. Attackers will encapsulate different network protocols within DNS in order to evade security devices. DNS is now used in many types of malware, particularly for command and control or CNC servers, in order to exfiltrate data disguised as normal DNS queries. An exploit of HTTP is called Iframe or inline frame injection. To address the alteration and interception of confidential data, HTTPS should now be adopted on all pages. It adds a layer of encryption to the HTTP protocol using SSL or secure socket layer, making that HTTP data unreadable. You have email protocols such as SMTP, POP3, IMAP that can all be used by threat actors to spread malware, exfiltrate data, in other words, pull the data out, or provide channels of malware for CNC servers. ICMP is used to identify hosts on the network and the structure and operating systems. However, it can also be used as a vehicle for a distributed attack or even just a denial of service attack in order to get data out. Attackers can determine IP addresses, protocols, and ports used by an ACL. This is either done by port scanning or penetration testing or other forms of reconnaissance. A lot of times, if it's a firewall, they're using what's called firewalking. Network address translation, or NAT, or PAT, port address translation, can end up complicating security monitoring as well, and it's all too common in most networks today. The problem is especially relevant to NetFlow data, which is unidirectional and therefore defined by addresses and ports that they all commonly share on the outside. Encryption can present challenges within the security monitoring because encryption is part of VPN technologies, and therefore when we use peer-to-peer networking, hosts can operate as both clients and servers. Three types of P2P exist: file sharing, processor sharing, and instant messaging. Tor is a software platform that uses peer-to-peer hosts to use internet routers, or that function as internet routers across the Tor network, and this can be used to browse the internet anonymously. Load balancing involves the distribution of traffic between devices or network paths to prevent an overwhelming network resources, too much traffic. This can be achieved by various techniques that use DNS to send traffic to resources that have the same domain name but multiple IP addresses. And so some load balancing manager devices use probes to test for performance for different paths and health services, therefore giving you false positives. All right, that's the end of module 24.